Hello everyone, today we are going to discuss some important questions for IIT JEE Advanced section. So let us discuss these two problems. The first problem is the desired product X can be prepared by reacting the major product of the reactions in list 1 with one or more appropriate reagents in list 2 at given order of migratory aptitude, that is aryl more than alkyl and hydrogen. So basically this is the desired product. And there are, in the list 1, we have a set of reactions. Now we need to know that in order to get this desired product X, what reagent will be used in these following reactions. So let us take, so basically this entire problem is based upon one reaction, and that is pinacol-pinacolone rearrangement. Pinacol-pinacolone rearrangement. So basically, what is pinacol? Pinacol is, let me discuss it here. So this is your pinacol. Suppose this is my, you know that this is your vicinal diol, and this is only pinacol. This is only pinacol, right? So I will describe the mechanism of the following reaction using first P reaction. So let me write P reaction here. This is the reagent, the reactant in P. Now this is my diol, this is pinacol, and in the presence of an acid, or say H plus, this OH will get protonated. Yes, but in order to protonate this OH, we will see whether the carbocation which is formed after the removal of water, after the dehydration, is more stable here or here. We know that if I get a carbocation over on this carbon number 1, then it is more stable because that will be resonance stabilized by these phenyl rings. So what we will be doing is, I will protonate this particular OH, will attack over here. This will be OH2 plus, and this will leave in the form of water. Then I get a plus over here. In the basically, now what will happen when I get a plus on this carbon? This particular methyl will migrate on this carbon. This group will migrate on this carbon. I will get a positive here. So what I will get is something of this sort. After the migration of methyl, now since I have two methyl, so it doesn't matter, I need to shift one of the methyl, and this is what I will get, and a positive here. In the next step, you know that I have the lone pair of electrons again on this oxygen, will be shifted over here. What I will get is this. Bond O, and in the last step this H can leave, giving you a ketone of this type, giving you a ketone of CH. Yes, this is called pinacolone. So basically this arrangement is to convert the diols into carbonyl compound. This is your pinacol. Now, you know that this is your methyl ketone. This is your methyl ketone, and methyl ketone can give, basically they give positive iodoform test. So suppose if I have iodine in the presence of a base NaOH, or I can also write it sodium hypoiodide, right? So this is for iodoform, this is your iodoform reaction. You know what you will get? You will get an acid like this, and the CH3 will be forming this yellow precipitate of chloroform, CHI3. So basically this pinacolone, this carbonyl compound that I get in the first reaction P, is reacting with this reagent I2 in the presence of NaOH in order to give you this precipitate of chloroform. This can also react with sodium hypobromite. Yes, this can also react with this, just like here. So this will also react with this reagent. So if you see in this question, the P reaction, you got a ketone like this. We got a ketone like this. Yes, and this ketone will react with, that means P will match with 1 and it will also match with 5. Now, since this is a ketone won't react with Tollens reagent. This is your Tollens reagent, ammonical silver nitrate. This is your Tollens and this is phalanx, right? So it won't show reaction with these two. And we also don't require this one because you need an acid over here, right? So P is going with 1 and 5. So if you see the correct option, so B, C, D can be the answer, but P cannot be the answer. Basically, P is going with 1, but at the same time, it is also going with 5. So let us see the second one. The second one. So I told you that this is your vicinal diol. Now suppose if I make it like this, I have a OH on one side, and at the other side, suppose I have NH2, right? So this is an example of semi-pinacol-pinacolone reagent rearrangement. So this is your semi-pinacol-pinacolone rearrangement, and here now in this question, if I tell you, now here I am given this HNO2. So basically this is for the diazotization reaction. You know that NH2 reacts with HNO2 in order to give you N2 plus. That N2 plus formed over here will leave in the form of nitrogen, and you end up getting a positive on this carbon. Right. After that, the same thing, one of the group from the adjacent carbon will migrate. Now, for which group will migrate? Because in the previous reaction, I had 2 methyl. Right. Here I have 1 methyl and 1 H. So if you see this migratory aptitude given in the question, alkyl will migrate in a better way than hydrogen. So basically the migratory aptitude is more for alkyl, right? So this will migrate, right? And this time, instead of ketone, you end up getting an aldehyde. So this is what we will get in this Q reaction. This time I end up getting an aldehyde instead of ketone. And once I get an aldehyde, so I know that aldehydes will reduce Tollens reagent. It will also reduce the phalanx solution, right? And yes, it won't react with this in order to give you the desired product. And yes, so it will react with Tollens and phalanx, and itself it will get oxidized to the respective acid. So this Q is going with 2 and 3. So let us see this. Q is going with 2 and 3, 3 and 4. Let us check 4. No, we won't require 4. So basically B and C are also eliminated and D is the right answer. So we have got the answer just by doing the 2 set of reactions, but we will discuss the third one also. Now this is again simple. In phenyl and methyl, it is phenyl that will migrate, right? It will phenyl that will migrate. So in our reaction, I will get something like this, phenyl, and this is again I get a ketone. So this time again R will go with 1 and 5, just like the first reaction. And in the last one, if you see carefully, this is also an example of semi-pinacol-pinacolone rearrangement where I have Ag plus. Now this Ag plus is for this Br minus. So this will leave in the form of Br minus and it will form a pale yellow precipitate of AgBr, and I get a positive over here. Again the same thing, this methyl will shift to this carbon, and what will you get is again an aldehyde. So again an aldehyde means that it will reduce Tollens reagent and phalanx solution. So basically this D is your right answer. So the entire question is based upon this rearrangement, that is pinacolone rearrangement, and we have seen the different examples of this reaction, right? We have seen the semi-pinacolone rearrangement also and the normal pinacol. So I hope this is clear to you. Let us move to the second problem. Let us move to the second problem. Here is our second problem. List 1 contains reactions and list 2 contains major products. Okay, so before we start the reaction, this question, we know that if I discuss with you Williamson ether synthesis, Williamson ether synthesis, then you know that suppose if I have the sodium salt of alkoxide and I have the alkyl halide, right? They react to give you the ether of this kind, right? But please note that this alkyl halide should be 1 degree. This alkyl halide should be 1 degree, right? If it is 3 degree, then the ether formation will not take place. Instead, you will get an elimination product, right? So for example, let us discuss the first one. You know that this is your 3 degree alkyl, 3 degree halide, 3 degree alkyl halide. So what will happen? You won't get a ether just like this third one. Basically, we will get an elimination product, right? So here in the first one, this moiety is not acting as a nucleophile. This is not acting as a nucleophile. It will act as a base, and hence it will abstract this. You know that this is your alpha carbon, this is the beta carbon, and at beta I have this H, so it will abstract this H, and hence there is a dehydrohalogenation, and we end up getting a product something like 4. Basically, in the first one, what will we get? This is your O negative Na plus a 3 degree alkyl bromide. So basically, what are we getting? We get an alkene of this type, an elimination product, plus obviously there is the formation of NaBr, and we will also get this type of alcohol. We will also get a tertiary alcohol. So this is your P. So if you see, P is going with 4, and I think you are also, yes, we are getting 1 also and 4. So P is going with 1 and 4. So P is going with 1 and 4. A and D are eliminated. Let us discuss the last one, because last one is one of the simplest. You know that this is your 1 degree alkyl halide. So here we will end up getting an ether like this. So S is going with 3. S is going with 3, right? And S is not going with 4. So we can easily eliminate the C option also, and I'm left with only B. So B is the answer. But again, we will also discuss Q and R reactions. So if you see this R may you will again get an elimination product, right? Because this is your 3 degree. So in R also, R will from R, in R we will get 4, and obviously we will get NaBr, and we will also get methyl alcohol. But the prime product is 4. So R is going with 4, and it is matching with our B option. Let us discuss this Q option. So this is the reaction of ether with hydrogen halide. So we know that, for example, if I have, so you know that suppose if I have an ether like this is the ether that is given in the question. This is the ether that is given in the question, and I'm reacting it with HX. So basically, I will see the bonds are around this ethereal oxygen. You know that if I break this bond like this, I end up getting a positive here, and this is your stable 3 degree carbocation. This is your stable 3 degree carbocation. So this X negative will undergo SN1 attack, and it will attack on this carbon, right? So SN1 attack is favored over here. SN1 attack. SN1 attack, and what is the answer? Answer is a 3 degree alkyl halide, but since it is HBr, so this plus you will get methanol. Will get methanol, right? But suppose if in place of here we got 3 degree carbocation, so if it is 3 degree carbocation or even more stable carbocation like benzylic, then we end up getting a product via SN1 attack. Otherwise, if there is a you are getting 1 degree carbocation or even 2 degree carbocation, then SN2 attack is favored. And you know that in SN2 the attack takes place at less hindered carbon. So if it would have been like this, so suppose if it would have been like this, then it is the SN2 attack that is favored here, and you would get, because in SN2 you look for less sterically hindered carbon, so attack will be on this particular carbon, and you would have got CS3X plus you would have got this alcohol. I hope this question is clear to you. So these are the two important problems from the IIT Advanced section. I hope you understood it. Thank you so much.